Let's talk about the interstellar object known as 3I Atlas. Why is it moving along such an unusual path? And how close will it actually come to Earth? These and other fascinating updates from the world of astronomy are coming up right now. These days, it seems like everyone is talking about 3I Atlas. It's truly an interesting discovery, but there's also a lot of speculation and exaggeration surrounding it. For example, some claim this third known interstellar object in recent years is moving at an unbelievable speed, something unheard of for objects in space. That's not entirely accurate. While its speed is indeed record-breaking compared to the other two interstellar visitors, it's not quite as extraordinary as it might seem. You probably remember Oumuamua and Comet Borisov. These are the only three objects ever recorded within our solar system that actually came from somewhere else, far beyond, from the depths of the galaxy. The first two, Oumuamua and Comet Borisov, approached the Sun with speeds of around 25 to 30 kilometers per second. That seemed normal, since nearby stars move at similar speeds relative to us. Our own Sun and its planetary system also drift at roughly this chaotic speed compared to neighboring stars. But 3I Atlas approached the Sun from deep space at about 60 kilometers per second. Among the three, it is the fastest. But is that really so incredible? All objects in the vicinity of the Sun exist within the galactic disk. Together, they orbit the galactic center at high speeds, around 200 to 220 kilometers per second. But that doesn't mean they move that fast relative to one another. We have long known the typical speeds at which nearby stars pass by us. It depends on the star. Newborn stars, formed from slowly drifting gas clouds, move more slowly, averaging around 10 kilometers per second. Stars like our Sun, which are middle-aged, tend to have characteristic speeds of about 30 to 35 kilometers per second. Older stars, born long before the Sun, sometimes zip past at up to 250 kilometers per second. So 3I Atlas, our intriguing visitor, approaches at 58 to 60 kilometers per second. Is that unbelievable? No, it's actually quite plausible. Discussing probabilities with only 3 examples of this type isn't very meaningful. There's a saying in statistics: once is an accident, twice is a coincidence. 3 times suggests a pattern, and 4 starts to become actual data. We can begin talking about statistics when a 4th one arrives. For now, 3 hints at some regularity but doesn't prove anything extraordinary. Yes, it traveled at 60, or precisely 58, kilometers per second. We move at about 30 kilometers per second, which is typical. 60 is just a bit above average. Think of driving on a highway. Some cars move a bit slower, others a bit faster. In different lanes, vehicles generally travel at similar speeds, but beginners might lag, while experienced drivers speed past. Average speed is just that, an average. Some will be slightly faster, others slightly slower. The conclusion: 3I Atlas presents nothing unusual in terms of its velocity. Still, that speed is quite high. If we ever hope to study such objects, visitors from other planetary systems, our current space technology isn't up to the task. Catching up with something moving that fast is practically impossible. But more on that later. Mars captures our imagination, but space agencies are increasingly focusing on the Moon. That's the impression you get from reports at the latest International Space Conference held in May. Countries like Russia, the United Arab Emirates, China, Turkey, Canada, and Japan shared their lunar plans. At such conferences, scientists connect, learn about colleagues' projects, and discover who is working on what and what results they've achieved. Events like these aren't limited to the scientific community. If you're interested in the world of IT, mark your calendar for October 8 and attend Select Tech Day. This flagship conference brings together business owners, top managers, and technical team leaders. The agenda includes talks on current technologies and real-world experiences in building flexible, resilient IT infrastructure. You can discuss key industry trends with people shaping the IT market. Meet experts, ask questions in person. The event takes place in Moscow at the Digital Business Space. Participation is free, but registration is required. You'll find the link in the description. Now back to 3I Atlas. Where did it come from? We'd love to know. We have precise data on how it entered the solar system, its direction, and its speed. The field of stellar dynamics, which deals with reconstructing orbits, has traced its path back in time. By looking at the motions of nearby stars over the past several million years, it appears that 3I Atlas never passed close to any particular star. It missed all neighboring stars, so we can't pinpoint its exact origin. If it had flown near a star, we might suspect that star's planetary system released it into space. Remember, 4 objects make a statistic. 3 is still coincidence. Some also point out that it's flying strangely, not just quickly, but also within the plane of the solar system, known as the ecliptic. That's true. The orbital plane of 3I Atlas is tilted only about 5 degrees relative to Earth's orbital plane. There's nothing unusual about that, it's just a coincidence. Its flight path is quite interesting, though. It passes by one planet after another, coming fairly close to them. Some suggest it might be deliberately aimed to study the solar system's planets. Let's go over its upcoming schedule. On October 3, it will make a relatively close approach to Mars, closer than with any other planet. Several spacecraft are operating near Mars, like the Mars Reconnaissance Orbiter, which has powerful telescopic cameras. There's hope that around October 3, Martian probes can be aimed at the comet for observation. This is a uniquely convenient situation because conditions will worsen afterward. After passing Mars and moving closer to the Sun, 3I Atlas will also approach Earth, but in a way that keeps them on opposite sides of the Sun. On October 29, it will make its closest approach to the Sun, but still at a distance similar to Earth's orbit. They'll be separated by about 300 million kilometers, and the Sun's glare will block our view. So, on October 29, it flies past the Sun and effectively past Earth. Then, on December 19, it will be closest to Earth, but by then it will already be quite far away. Then, on March 16, 2026, it will pass not too far from Jupiter. Jupiter is extremely massive, and even at a distance of 270 million kilometers, its gravity will slightly alter 3I Atlas's trajectory. After that, it will leave the solar system at roughly the same speed it arrived, about 60 kilometers per second. Honestly, it's a favorable situation. We'd prefer if it came closer to Earth, but that's just how it is. Still, the thought lingers. Could this be an alien spacecraft? Maybe it disguised itself as a comet, creating a gaseous coma to appear natural when it's actually a probe. As it passes Mars, the Sun, and later Venus on November 3, it could use their gravity, or even activate its own engines, to turn toward Earth. That possibility exists, especially if it's an advanced vessel. We'd love to think it's intelligent life, but that's doubtful. Most likely, it's a comet. Right now, we see it approaching from a distance. When it passes the Sun, we won't see much. Later, as it moves away, we can aim telescopes like the James Webb, the most advanced space observatory today, to study the gases evaporating from it. We've already learned something. It's not quite like comets from our solar system. Our comets, heated by the sun, mostly release water vapor. But 3I Atlas mainly gives off carbon dioxide. That makes you wonder where it formed. Carbon dioxide evaporates at lower temperatures, suggesting it condensed in the colder outer regions of its original planetary system. We'd love to analyze its chemical composition in detail. Let's try to do that. The mysterious object 3I Atlas, which came to us from another star, is the biggest space mystery right now. Even scientists don't agree on whether it's a comet or something artificial. 3I Atlas continues to approach Earth as researchers study it closely. On October 18 in Moscow, there will be a public discussion about this puzzling visitor. Astronomer Vladimir Surdin and Leonid Elenin, an expert on comets and asteroids, will share the latest findings, debunk myths, and explain what is reliably known. Come join us to figure out what 3I Atlas really is. October 18 in Moscow. Tickets are available via the link in the description. Each time, and this is the third in astronomy's history, we're disappointed we weren't prepared for such a visit. These objects move fast and appear unexpectedly. Astronomers watch in awe and then they're gone, out of reach of any telescope. Within our solar system, we calmly calculate trajectories, prepare in advance, and send probes for close-up study. Remember the Rosetta mission a few years ago? It approached comet Chelyabinsk, entered orbit, and even dropped a lander onto the comet's solid nucleus. We studied it thoroughly, its gases, isotopic composition, even attempted drilling. That's how we should study interstellar comets and asteroids, but it's not that simple. Space missions take years, sometimes decades, to prepare. And the journey itself can be long, but there's no rush. These objects are part of our system. We can approach gradually and enter orbit. But interstellar comets don't give us that chance. They speed in and leave even faster. So we need to prepare, to set a trap, so to speak, like a hunter waiting for prey to come within range. But these celestial visitors move extremely fast, while our interplanetary probes travel slowly. Catching an interstellar asteroid or comet is like trying to chase a Ferrari on a bicycle. You won't succeed. But if the Ferrari is heading straight toward you, even a bicycle could get you close. But I don't recommend it. Better not to collide. Our spacecraft will never catch an interstellar object moving at 30 to 60 kilometers per second. Our rockets travel at maybe 10 to 20 kilometers per second at best. So how can we study them? We need a probe ready and waiting in position. When astronomers spot an interesting interstellar object in the distance, they can calculate its path and send our slower-moving research craft to the meeting point. No matter how slow it is, the encounter will happen. Orbiting might be difficult, but a close flyby would allow detailed photos, gas analysis, and other studies in a short time. That's the plan. And such interplanetary ambush probes are already in development, waiting for the fourth, fifth, and future interstellar arrivals. Doesn't it surprise you that for centuries, with telescopes, astronomers never spotted an interstellar object? Yet in just the last 7 or 8 years, we've found 3. Is that random? Some say no, it must be an alien fleet heading our way. I think the reason is different. In recent years, astronomers have gained incredibly powerful optical tools. And for that, we should thank, well, you know what? We should thank the Chelyabinsk meteor of 2013. Before that, we lived calmly. Then this fairly large body streaked over the southern Urals, creating a powerful shockwave that shattered windows, damaged roofs, and injured people. That made astronomers and leaders in many countries realize we need resources to defend Earth from unexpected visits, and we got them. Since 2013, robotic telescopes with wide fields of view, scanning large areas of sky, not just single points, have become increasingly active. That's why we're now discovering many previously unnoticed objects. In recent years, we've found nearly 1 million asteroids and comets in our solar system. And now, visitors from the far reaches of the galaxy. So it seems this will now happen regularly. We'll detect interstellar objects maybe every 2 or 3 years, or even more often. We need to be ready and take advantage of this unique opportunity to learn not just about our own planetary system, but about others around distant stars. While 3I Atlas grabbed the world's attention, astronomers haven't forgotten the first 2 interstellar visitors, especially the very first one from 2017, Oumuamua. It surprised everyone, first with its shape. Of the millions of asteroids we know, most are roughly spherical or lumpy. None were like Oumuamua, shaped like a cigar. Or maybe it was a disk seen edge-on. Either way, it amazed astronomers and sparked theories about its origin. The most obvious was that it might be an alien spacecraft, but that idea hasn't been confirmed. Another interesting theory suggests it was made not of rock or water ice, like our comets, but of nitrogen ice. Nitrogen evaporates easily, even at low temperatures. If it had a slightly flattened form, evaporation over time could have made it more disk-like or elongated. That's intriguing. We haven't seen nitrogen ice like that in space before, but in our solar system, there is something with that composition. The dwarf planet Pluto. Its surface has large nitrogen icebergs and frozen nitrogen plains. It seems Pluto is one of many small, Pluto-like bodies that once populated the solar system, and there are still plenty out there in the outer reaches. Probably, other planetary systems have them too. In their youth, when planets competed and collided, fragments like these were sent flying through other star systems and into interstellar space. So Oumuamua may have been one of them. Its nitrogen composition could also explain its second peculiarity. It accelerated slightly as it moved away from the sun. That could be explained by artificial means like engines, but a natural object could also produce a jet effect. Gases evaporating from the sunlit surface would stream away from the sun, creating thrust and speeding its departure. That natural explanation, without invoking little green men, seems a solid scientific hypothesis for what the first interstellar visitor really was. Lately, we often see interesting suggestions in the comments on our podcast. Viewers frequently recommend topics for future episodes. In recent weeks, a very popular subject has been a Chinese video showing what appears to be an anti-aircraft missile striking some kind of space object entering Earth's atmosphere. What was it? Unfortunately, Chinese media provided very little information, almost none beyond the video itself. It shows something entering at a shallow angle, with bright fragments breaking away. That phenomenon is what astronomers call a meteor, but it could also be a natural object, a rock or icy body, or something artificial, like an old satellite or rocket part falling to Earth. That happens regularly. What surprised everyone was that something launched from the ground toward this incoming object. In the video, a bright dot moves quickly, closing in, and then an explosion destroys both. I don't know exactly what it was. It's possible it was intentionally deorbited. Russia, China and India test anti-missile or anti-satellite weapons, they sometimes use old satellites as targets. So my impression is that this was a test of an air defense system, using a retired Earth satellite as a practice target. That's my personal view, based on experience. Continuing on this topic, we should remember it's not just artificial satellites that fall. Natural asteroids and comets sometimes hit Earth too. We'd like to protect ourselves from their destructive effects. How? Astronomers can do half the job, predicting when something might threaten Earth, which we do regularly. The rest is up to engineers. Either deflect the object from a collision course or, if impact is unavoidable, break it apart to prevent a single devastating strike. Why avoid breaking it? Because turning one rock into shrapnel means many fragments whose paths are hard to predict, and we just have to wait for the unpleasant consequences. So we've long aimed to predict such visits centuries in advance and develop methods to prevent them, perhaps by sending a spacecraft to nudge them slowly away. But there will be unexpected discoveries when we have only a year and a half, or even months before impact. By then, gentle influence won't help and we'll have to destroy them. The question is how. We need to test this experimentally, strike a celestial body and see what our space technology can achieve. You may recall an experiment several years ago, NASA's DART mission. In 2022, the DART spacecraft approached a fairly large asteroid named Didymus and struck its smaller companion, Dimorphos. The goal was to see what would happen. Predicting the outcome was hard, which is why they tried it. The result was surprising. Although our impactor was small, it significantly changed the asteroid's orbit. Physics tells us that when two bodies collide, momentum is transferred, like billiard balls. But what happened was different. The spacecraft plunged deep into the asteroid, which was quite porous. The energy from the impact heated the material, creating a shockwave that blasted material away in the opposite direction. It acted like a natural jet engine briefly, but had a much stronger effect on the asteroid's motion. Here's an analogy for physics fans. Imagine a rocket filled with fuel. If you just burn the fuel inside, the rocket gets hot but doesn't move effectively. But if you channel that fuel through a rocket engine, ejecting hot gas in one direction, propelling the rocket in the opposite direction, the same energy, applied differently, produces a very different thrust effect. The DART experiment showed that a high-speed impact on an asteroid can create a jet effect that effectively pushes the body away. Not only was momentum transferred, but the energy of the small impactor's flight was converted into reactive thrust. That's very useful. Small hazardous asteroids are constantly heading our way, and someday a big one might come. Now we know how to handle them. In the coming years, Hunter probes may wait in orbit around Earth, ready to intercept any dangerous object that approaches, altering its path and preventing a strike on our planet. It's been almost 4 years since the incredible James Webb Space Telescope began operating not far from Earth. It makes amazing discoveries daily. The telescope is just one, but it has many tasks, studying distant galaxies, planets in our solar system, and exoplanets around other stars. Unfortunately, one space telescope can't satisfy all astronomers' wishes, so observations are planned with extreme care to maximize scientific returns. When it comes to studying exoplanets, Webb's capabilities are outstanding, but we need methods to get the most valuable data. Recently, such a method was found. You've probably heard of the remarkable exoplanet system TRAPPIST-T-1. TRAPPIST-T-1 is a small red dwarf star not too far from our solar system. It has 7 Earth-like planets, with 3 in the zone where life could potentially exist, not too close, not too far from their star, in the range where temperatures might allow liquid water. Especially promising is the planet TRAPPIST-1e. Why? Because its surface temperature should be similar to Earth's. That should favor the presence of water if it's there. But physicists point out that liquid water requires not just temperatures between 0 and 100 degrees Celsius, but also sufficient atmospheric pressure. On Mars, near the equator in summer, temperatures can reach 15, 20, even 30 degrees Celsius. Yet there's no liquid water. Why? Because Martian atmospheric pressure is 160 times lower than Earth's. At such low pressure, water boils at any temperature. So ice sublimates or liquid evaporates quickly. It was crucial to find out the atmospheric pressure on TRAPPIST-1e. If it's high enough, say half of Earth's, and the temperature is right, liquid water could exist. That's an ideal condition for life. How to check? We needed to examine the planet's atmosphere. That's difficult. For a long time, observations weren't precise enough. Then astronomers found a way. They love comparing similar objects to detect tiny differences. In the TRAPPIST-1 system, besides planet E, there's another planet, B, much closer to the star. Planet B is intensely heated and likely has no atmosphere. But it's similar in size to planet E, so they devised this. Wait for a moment when planet B and planet E transit almost simultaneously in front of their star. All 7 planets in this system regularly pass in front of the star, but it's especially interesting when they cross at nearly the same time. The star itself doesn't change much in those few minutes. Now imagine, planet B passes, blocking some starlight, and then right after, planet E transits. By comparing the spectra taken just before and just after, we can look for small differences related to the presence of an atmosphere. This is called the differential method. It greatly improves measurement accuracy. Now they're waiting for such a moment to investigate whether TRAPPIST-1e has a dense atmosphere. If so, liquid water could be present on its surface. Then it might be time to plan a mission in search of extraterrestrial life in the TRAPPIST-1 system. Friends, I want to share some good news. About a year ago, I mentioned a wonderful book I had a small part in. I'm not the author. It was written by a talented young writer, Ekaterina Ovsyannikova. This was her first book. She created a new genre of science fiction aimed at school-age readers, fans of Harry Potter, but with a space theme, grounded in real science and technology. After writing it, she asked me, as an astronomer, to check for technical or astronomical errors. I reviewed it, fixed a few minor points, and realized the book was missing something. The story involves a young crew on an interplanetary ship traveling to Venus, exploring its surface. There are excellent maps of the Venusian surface, by the way, created at our Astronomical Institute. She liked the idea but doubted we could get permission to use them. My colleagues agreed to grant the copyright to the publisher, essentially donating the maps for the edition. So in every copy, we included a large, fold-out map of Venus, a real detailed map with many geographical features. You can hang it over a bed or desk and explore the planet's surface. The idea worked. The book found its audience. Then I told Ekaterina, we have maps of other planets too, so she wrote the next book. This time, the young crew journeyed to Mercury. And in every copy there's a map of Mercury, full of surprising geographical details. Astronomers decided to name features on Mercury after famous writers, artists, composers, people from the arts. So you'll find plenty to explore. And now, a third book has just been released. I'm holding it now. It might not even be in stores yet because it's just been published. The next adventure takes the crew to the Saturn system. They didn't land on Saturn itself. It has no solid surface, being a gas giant with an ocean of liquid gas. But Saturn has a remarkable moon, Titan. It's an incredibly interesting world with an Earth-like atmosphere, practically the same as ours. There are oceans, rivers, and seas. What fills them? You'll find out when you read the book and see the geographical map of Titan, a real map, not invented like the fictional island in Jules Verne's The Mysterious Island. Each of these maps is an actual chart of a real planet. The journey, while fictional, is written in the style of hard science fiction, where every detail aligns with science and technology. That's all the space news for today. Next time, more updates. To make sure you don't miss new stories about the cosmos, subscribe to the channel and hit the bell icon. Let's find each other in the cosmic vacuum. If you enjoyed this journey through the stars, show your support by liking this video, sharing it with friends, and subscribing for more cosmic discoveries. Your engagement helps us